All right, welcome to GD50. This is lecture 10. Today we'll be talking about Portal. So Portal is a very iconic game. I think most of us have probably seen it before. The gist is you have a portal gun, a gun that shoots just these elliptical portals. If you look through one, you can effectively see what's sort of coming out the other one, which is pretty cool, and vice versa. And then if you walk in between the portals, you'll actually be teleported to the other side. And so they achieve a lot of really interesting effects with some pretty cool tricks and stuff. And actually, Valve themselves will be coming to give a talk on a lot of the technology that they used on the second, so we can get a glimpse into their version of Portal. My version of Portal is a bit simpler. But we'll look at a lot of the same sort of principles and see how I accomplished a lot of the same things. So this is also the last lecture of the semester, and we've covered a lot of ground. I have a few screenshots here to show some of the games that we've talked about. You know, the very first game was Pong, and we've come sort of a long way. We've gone through very simple sort of arcadey, Atari-like games like this, and have gone and created worlds effectively, and now we're in 3D. We're doing all kinds of awesome stuff, but this was where we started the course. And it's kind of fun to look back and see where we've come. So, here we talked about scoring and just effectively drawing shapes onto the screen. Then we transitioned to Flappy Bird, or 50 Bird, and we had sprites and characters, and we talked about scrolling and infinite level procedural generation type algorithms, and that was fun. We took things a step higher than that with Breakout, where we had the same sort of procedural ideas in the context of a very famous arcade game. And we talked about particle systems and some arcade-style physics and high scores. Then we went into puzzle games. We talked about Match 3 and how to actually calculate what goes on to determine whether we've gotten a match, and how to clear blocks, and how to tween things, do operations over time, so this asynchronicity. Then we went into probably what is my favorite lecture, which was Super Mario Brothers, and we talked about how to create procedural worlds that all look very different with some very simple algorithms. And then we had triggers and events sort of happening. Then Legend of Zelda came, and we had this infinite dungeon algorithm, and we had enemies walking around that we could use a sword on, so it felt more like an actual action game, action RPG. Then we took a brief look at physics in the context of Box 2D with Angry Birds, and I still remember the ball pit example was probably my favorite part of that. And then probably the most complicated example of the semester was Pokemon, where we actually had a semi-full turn-based battle system, and random encounters, and a little world where there's actually two main stages to our world, where there was the field and the battle scene, which is a very common thing to have in RPGs. Following Pokemon, which was the most complicated code base, we went into Unity, which was our first foray into 3D. And even though we were just exploring 2.5D, we still got a chance to look at, how does the Unity engine work, and how do we get actual 3D models onto the screen. And we put together a very simple Flappy Bird-esque game so that we could sort of recycle prior ideas. Last week, we looked at Dread 50, which was sort of a Dread Hall's horror-inspired game where we got to look at lighting and how to actually transition between scenes and use some basic UI in Unity. And today we'll be talking about how to create a game similar to this, although much simpler. Today is mostly just a tech demo more than anything else. But this is a screenshot of the actual game Portal. And as you can see, they do a lot of really cool fancy things. They have a portal on sort of a slope. They have another portal coming out of the front wall or back there, different colors, so you can differentiate between left and right, orange and blue. They have sort of this object here on the side, and I believe that's to shoot cubes out, which this here is a cube, which you can then grab with your gun and then shoot it through portals and see it come in and out of portals, which is pretty cool. And we'll talk today about how to create sort of a simple version of this, primarily just the aspect of how do I create a portal that looks out of another scene and see it updating in real time. And how do I teleport and get back and forth between the portals and carry a weapon and then shoot a ray that'll actually place a portal where I want to in the game world. So today, some of the topics we'll talk about. So one, holding a weapon. So we've used a first-person controller, and this is a very easy and simple thing to do, but it helps illustrate what parenting is, and so we'll talk about that. Raycasting is the actual shooting out a ray from your object's Z direction forward. So you have an X and a Y, which are sort of the angle at which you're moving around, but then you have Z, which is always, if you're using the forward vector from your character, it's going to be forward in the Z axis wherever you're looking effectively. And so that allows us to we can cast a ray in that sense, which just means shoot a straight line, an invisible straight line from that point, and wherever that point intersects with an object, we can get some information about that and then do whatever work we need to do. In this case, take a portal prefab and just like affix it to the wall, basically, rotate it from its default position, and then just like put it flat up against a wall. Texture masking is sort of how we're going to achieve this portal effect, right? Because when we create what's called a render texture in Unity, which here's the third bullet, a render texture just means a texture that we are rendering to with a camera. So rather than have a texture be an asset in your game, in your hierarchy, with something that you've made in Photoshop, you can actually dynamically create it at runtime with what the camera is seeing. And Unity gives this to you for free very easily with what's called a render texture, which is just another asset type. And then texture masking is effectively sort of kind of the same thing as stenciling, where we can choose certain pixels of an object to delete. In this case, we create a texture that's white in the center and then black around the edges in a sort of elliptical shape. And what that allows us to do is tell it with a simple shader, don't render these pixels when you actually render the render texture, just render the ones in the middle. And so that's how we achieve an ellipse, just by effectively discarding the pixels on the outer rim. Decals is an idea in 3D games where a decal is just something that you affix a texture or some object that you affix to a surface. In this case, we'll be using decals to act as our portal. So our portals are actually just going to be decals. They're just meshes with a render texture affixed to them. And then all we need to do is just sort of slap them onto a wall whenever we shoot it, and we get a ray that intersects with the wall. And that'll have the effect of actually making it look like we're putting a portal on a wall, when in reality we're just taking a mesh and we're just kind of like slapping it onto a wall. Some other examples of decals that you've probably seen in other games are, for example, bullet holes, which use the same principle. Teleporting is very easy, although the FPS controller sort of complicates things a little bit. So we'll talk about how I went about sort of solving the problem of teleporting in a way that makes sense. It's usually just as simple as a change on the, setting something's transform's position to another transform's position, setting the rotation to the transform's rotation. But the FPS controller caches its rotation data. So in order to do that teleport cleanly, you sort of have to override some default behavior. And lastly, we'll take a look at some new tools that Unity has introduced with 2018.1, ProBuilder and ProGrids, which allow you to actually model geometry in the scene. And this is what the assignment is going to be focused on. Because going forward, I foresee it being a major part of sort of modern Unity development and or prototyping. The ability to model your scene in Unity without needing a third-party program heavily optimizes the actual creation process and allows you to do easy what's called gray boxing, meaning create a level for create a level in your game engine and then prototype it, test it, make sure that it's actually game playable right off the bat. That's called gray boxing. But first, let's get a demo. So does anybody want to come up here and play my implementation of Portal?
I'm landlocked.
That's true, James is landlocked. All right, James, you're not landlocked. Let's go. All right, so I'm going to go ahead and set that up. And so disclaimer, there's actually a bug in this as well. So I'm curious to see if you can spot what the bug is. Okay. Go ahead and hit play as soon as you're ready. And then the mouse on the right will be your sort of angle of your portal. So we see here I have a character with a portal gun created. So James, if you shoot a wall with the left mouse, that'll create a portal. And then if you use the right mouse, so that's one other bug. So let's go ahead and restart the program actually. So that's one bug. And so if we avoid stepping into a portal that's there, and this could be fixed in a couple of ways. So now you have two portals basically created. Do you see what's wrong with the portal as it is here? Both of these portals actually?
Characters invisible?
Oh, actually, no, I'm sorry. These portals are actually completely right. But walk through them. And I will show you, okay, so you can see it works pretty well, right? You can not only see your character rendering completely, or moving in real time when the other texture, but you can jump through them or walk through them. You can jump with spacebar if you want. And that'll teleport you out the other end so you see from the perspective of the other portal. But if we try shooting one of the other walls, for instance, like one of these white walls, you can see something weird happens with this particular wall. Anything strike you as odd about that portal? Anybody? It's upside down. And so if you walk through it though, it works perfectly fine. Now the reason that it's upside down, I spent probably like 10, 15 hours trying to debug why this is. It's in a state of what's called gimbal lock. So this prefab right here, there's 3 axes of rotation in 3D space. And if you perform a rotation in some odd way, there are these things called Euler angles, which are your angles of rotation about the X, Y, and Z axis. And you can sort of think of them as sort of being able to rotate interdependently. But there is a situation in which you can, for some reason, Unity's internal representation of a rotation can get messed up by manipulating these angles. And so you can actually lock 2 axes together such that rotating, like for example, in this case, it's Z and Y, they both rotate each other. And so you're unable to get, in this particular case, the portal to rotate about the axis that lets it like look like it's right side up based on the wall's surface normal. And so had I maybe another week, I probably could have debugged it, but I had to leave it in. Unfortunately, I ran out of time. But if you don't, the interesting thing is if you do shoot that same wall, so try and shoot that wall, the other wall with, like put one portal on the buggy wall, so the right wall. It's only that wall, by the way, for some reason. So that wall is a bit, so notice that now it's right side up. So if you shoot both portals on the same wall, that buggy wall, they do get right side up. And I, for the life of me, couldn't ascertain exactly as to why. I know it's gimbal lock. Unfortunately, I was unable to debug it quite in time. But every other wall, including the ceiling and the floor, will work if you shoot a portal up on them. So you can create one up there, and then you can jump through it, see how it's looking down, and it'll sort of put you at the top. And altogether, minus the weird single wall that gimbal locks the portal, we have a pretty functional implementation of a very basic portal game, right? We have this model here is parented to the camera, so it's always going to look in the exact same direction as the camera. We shoot a ray from the tip of the gun, and then whenever that ray intersects with a plane, in this case any of these walls, we get the information about the intersection, and we flip the decal, the portal decal, such that it's the same angle as the wall rotation. And then what happens when we actually collide with one of the portals, just in code, if we were to think about how to implement like the behavior that goes on here?
It's transporting the player?
It's transporting the player, and it's doing effectively setting the player's transform position to the same transform position as the portal. Now, if we do the same thing on the rotation, the player ends up getting a bit, the FPS controller's rotation gets a bit skewed if you mess with its X and Z rotation, the default controller. So all we do for now is we keep those values, the X and Y rotation, but we just change the Y rotation. Y rotation is his position in space like this, effectively. So that allows us to get, when we jump out of the wall, we notice that he's, sort of like flat from it, but if we jump through any of the wall portals, so if you like create a portal on the wall here, and then jump through it, you'll notice that you sort of get a, you're sort of angled at the right, and the reason that it's skewed is because this one's upside down. And so it flips it's flipping the camera that's rendering the texture, and it's looking a little bit weird. But when you jump through, it basically keeps your X and Z, but rotates your Y position, such that you come out looking as if you went straight through the portal, rather than by default, it has you look back at the portal that you came out of, which is a bit weird, or whatever direction you were walking through it when you went through the portal.
How are you getting the mirror sort of thing so you can see yourself?
That's just default, because it's rendering it's a render texture. So there's a camera actually behind each of these portals. So the prefab is a mesh with a render texture, and then behind it there's a camera. And so the camera is rendering in real time what's in front of the portal, basically, from behind it. And so it's seeing your model from both of these portals. Both cameras are seeing your model, and so it shows up in the render texture on the other portal. So it's effectively like looking at 2 video cameras instead of a portal. It's a sort of a trick. And this is a very crude implementation of Portal. The actual game uses a much more sophisticated algorithm for, and it also tracks your position with the camera, so that, like, based on your angle of rotation, you'll actually see something different on the texture there. but it's a lot more complicated to put something like that together. I have some resources that I've included in the lecture and the assignment that'll show you actually how to do that. But it would take many, many more hours than I had to put this demo together.
Because right now it's just fixed.
Yeah, it's fixed. So if you actually look at it from the side, you'll notice that it's like just a flat texture. There's no perspective. Ultimately, it's perspective. And there's an awesome video that I'm going to show later in the slides by a YouTuber named Brackies, where he actually implements a perspective correct shader that allows you to see, and with camera tracking of the player, like both cameras will track the position of the player as well as render a texture. And the result of that is, because the cameras are changing their position, it's sort of like changing the angle at which the scene is being rendered onto the portal mesh. But also the way that it's being drawn is a little bit different. And so he has a really cool shader that does that. And then Valve, when they present, they'll actually show how they went about doing it, which is even more complex, but looks really good and is a lot more, technically interesting. But yeah, that's my sort of implementation, bare bones implementation of what makes Portal work. So, and it's somewhat fun to like walk through these, walk through these portals and just sort of play around with it. Now, the reason that if you just walk into a blue portal, it doesn't work is because the portals are actually stored off screen until you use them. And so a way in which, so I'll open up the scene here. Oh, by the way, thanks James for coming up to demo, I appreciate it. So the portals are over here, right? Both of them are right here. And so what that does is when you only shoot one of them, the other one is still out here. So when you walk through it, you end up just teleporting outside the level. And in order to not have that happen, what you really need to do is have a flag on both of them that just says, don't teleport unless they've been shot once, right? And that'll prevent that sort of behavior from happening. Simple fix, but an entertaining one to take a look at. And that is my crude implementation of Portal. It's far from being anywhere near as polished as the actual game. And there is the slight weird wall that gimbal locks the portal, which I would like to figure out why exactly that is. But everything else is sort of in here. Now, it doesn't include something like shooting blocks through it, but the same sort of principles would apply, because all we're effectively doing on the portal is saying, it's basically a trigger, right? It's got a box collider on it, and it says, if I collide with something, and in this case the player, I want to teleport that collider to the other portal, which means that the portals sort of have to link to each other, right? One portal has to have a reference to the other portal so that it can say teleport to the linked portal, and vice versa. The linked portal should have a reference to the other portals that can say teleport back if you collide with this. And so if we have another object, like say we shoot a cube into the portal, it would also get teleported to the other portal, right? And now the other consideration for that is like if it's a rigid body and it has physics applied to it, for example, let's say it's going like 10 on the X and it teleports to a portal that's like perpendicular to it, and it's still going 10 to the X, then as soon as it shoots out of the portal, it's going to go straight left, which isn't the behavior we want. We want it to go forward. So it's like linear velocity needs to be calibrated to go in a different direction. Didn't have enough time to put a full demo of that together, but if you were curious, in a nutshell, that's sort of like what you would need to do in order to implement like some basic physics with Portal. So holding a weapon, based on the screenshot, can anybody tell me how they think I went from just a plain FPS controller to an FPS controller holding a gun?
You just stick a gun, like one, I don't know what, do they call it pixels? One unit in front of the camera.
Yeah, there's not really a notion necessarily of pixels in 3D space because that changes depending on your resolution. But yes, Unity units, so it's effectively equivalent to a meter, and you can change what it represents in Unity settings. But yeah, I mean, it doesn't necessarily have to be one unit, it can be an arbitrary amount. And what it really was me going into here with this model. By the way, got this model on the asset store for free. So the asset store is an awesome place if you're looking to just quickly prototype your game. They didn't have any like obvious portal gun lookalikes that looked really good. So I was just like, oh, this gun's got like the same kind of color. I'll just choose this. It's like a sci-fi kind of gun. But as you can see, there's a hierarchy here. Now, how are we keeping the gun like affixed to where the camera's looking? Do we know?
You do the same thing follow the, sorry, you have the camera follow the gun or vice versa.
You have the camera follow the gun. Do you have any guesses as to how we're doing that? It's actually a really, really simple thing.
I know I'm doing it, but I've never verbalized it.
So all we're doing, oh, Steven, did you?
I was gonna say, do you set the cameras like transform like as like you relate this is transform kind of to the guns transform like with an offset in like same direction but like just position offset?
Yeah, kind of. So set the guns transform to the cameras transform, but just with an offset. I mean, that is effectively what we're doing. And in order to accomplish that, it's really as simple as just making it a child of that thing. So this is the first-person character controller. It's got a camera attached to it. Anything that you parent to something, or you make a child of something else, it's going to have the same transform like changes applied to it, including rotation. So by making the gun just a child of the first-person character, which is where the camera is here. First-person character, by the way, is just a subcomponent of the FPS controller, which I've renamed to Portal Gun FPS controller here. The portal gun, anytime this first-person character is rotated, which is the camera, so anytime the camera is rotated, it applies that rotation to the portal gun here, this gun mesh. And so that gives you the effect. So what you do is you start it off by, you figure out, okay, you start off in 3D space like this. You're looking at your game scene and you have your character, and then you move your gun object around. In this case, let's go to layouts 2x3. So we can see it in real time. See, this is the game view. This is what it's going to look like on startup. I'm going to go over to my editor view here. And I'm just going to grab the actual gun component here, the gun object, I should say. Go in and position it, and I can just move it, right? And so this is how you can change where your gun is relative to the camera. And this is going to affect sort of how it feels, right? Like I could put it here and it's kind of a little lower. I could put it here. It feels a little weird, obviously, because it doesn't have a hand on it. So it's kind of almost looks like a VR game. And that's kind of like what VR games do, is they take your hand positions and then they the gun transform is locked to basically where your hand controllers are. In this case, all I did was I just positioned it. I said, I like how it looks right here. So I'm just going to do that. And as soon as I make it a child of the first person character, which is the camera, it's just going to get all the rotations applied to it. So anytime we make any rotations to the camera, which I'm doing here, it stays exactly aligned with the camera. This applies to any operation that you do in Unity. When you make any sort of transform, position, scale changes, they all get propagated down the chain. All the objects that are children of an object that get transform operations applied to them will have the same transform operations applied to them, sort of like this recursive kind of effect. Yeah?
So if you import the first-person controller, right, that automatically has jump and move left and right, and then you just move your asset, your gun, to be underneath that controller, it'll just follow?
Correct. So if you just import the vanilla FPS controller and then just make the gun, specifically the gun needs to be a child of the first-person character bit, because that has the camera, and recall the camera is what's driving our rotation, right? Because we're moving the camera's rotation with our mouse. That is ultimately going to determine how the transform gets applied to the gun. But yes. And so just whenever you're doing anything in Unity, and you'll do a lot of things where one thing's movement or scale or rotation should apply to another thing, just remember that it's usually just as easy as making it a child of something else. So any other questions as to how we've gone about implementing the weapon? All right. So raycasting. So raycasting is a nice feature that Unity gives you for free. It's part of the physics sort of namespace in Unity, part of the scripting API. And what it allows you to do is effectively look at from whatever transform you're operating at, or whatever transform you give it as the source, so whatever point you give it as the source, you can tell it a direction, give it a vector as a direction. In this case, what we're doing is we're saying transform.forward, and transform.forward just means basically wherever we're looking x and y, and then straight in the z direction. So if you're doing it on a camera, it's always going to be exactly what you're looking at. It's always going to be exactly forward on the, transform.forward on a camera is always going to be center of the screen wherever you're looking at. And so if we cast a ray from the point of our character, or actually we're doing it from the point of our gun, to the transform.forward, like a line going from our player to transform its the forward vector of its character, the forward vector of our camera, it's going to have the effect of we can shoot something, right? We can create a raycast and then just like affix something wherever that ray intersects, and it'll be at the exact center of our camera view. Does that make sense? So shoot a line from your Z axis, which is your forward vector, and then based on how you've rotated the camera, X and Y are the X and Y part of that, and Z is always forward, that'll let you shoot things or cast rays directly in front of you. And you can cast rays between any object and from any source point with any sort of direction you want, but it's particularly pertinent in the context of how we've shot it from our gun. And so here's a screenshot actually of what that looks like. And so the nice thing about Unity actually is it has a function called debug ray, or debug.drawRay, which I'll show you here. I implemented it in a function called a component rather called debug ray, so that you can actually see where a ray is being cast in your scene and eliminate any ambiguity there. So you can see draw ray, transform.position, and then we just say transform.transform direction vector3.forward, and then times 1,000 just means 1,000 units, from that point, and then color.red. And so what that'll do is only in the editor view. So this doesn't apply in the actual game. This is just a debug call, debug.drawRay, and so it'll render in this scene up here, just not down here. So if we hit play, I actually have all the portals rendering a debug ray from their forward transform and from my gun. So you can see it there. I'm just doing a debug.drawRay with just transform.forward and using my transform.position as the source point. And forward is always going to be, notice that the Z arrow, it's always following the same direction, right? X and Y are sort of changing, the back plane, sort of like how that's rotated, but Z is always forward, right? And so that's the ray coming from our gun. And if we shoot a portal there and there, I have those also set to, here, let me pause this so I can rotate the view a little bit. I have those also set to draw a ray from their forward position. So those are also drawing a ray from what's their vector3 dot, or their transform dot forward, their directional vector. But yeah, raycasting, it's pretty easy just to get some pretty simple collision tests this way with guns, with a lot of different things. But primarily you'll see this used for like calculating whether something is blocking something else. Like if a car is moving and it detects, maybe if it detects another car, like if you're in Grand Theft Auto, for example, and your car is driving down the center of the road or something, and it wants to know whether there's a car 2 units in front of it or something, it just casts a ray and see if there's any geometry there from its forward vector, right? Transform.position, car.position, and then get its forward vector, which will be its Z direction. And then it depends on whether maybe your game's top down, maybe it's not your forward vector, maybe it's your Y vector in that case. But that'll effectively give you not only that you got a collision, but also tell you where the collision is too, which is nice. And we do that in the portal gun script, where we call physics.raycast. So this is the function, by the way, to actually do the raycast. The interesting thing about raycasting in Unity is that it returns a struct object, and so you need to declare this hit object, which will tell you all the information about the hit, sort of like where it was, whether there was a hit to begin with, and what the normal was on the surface that it collided with, so the angle at which that sort of plane was projecting out. And then you call physics.raycast with a position and a transform direction, and then you pass in out hit. So out is interesting because out is sort of C#'s way of allowing you to return multiple values to something. So out is going to be an object, in this case it's going to be our raycast hit that we declared up here, right? Which is a struct, which recall is just a collection of variables like in C or C++. And out hit just means that normally we pass in these values to the function, they don't get manipulated, right? But we pass in this variable as out, which will allow this function to actually change the data inside this hit variable. And so the result of that is hit from this point forward contains all of the information about the raycast that we just triggered. And when we call mathf.infinity, that just means raycast to infinity, which is until forever and ever. And Unity obviously doesn't check infinitely whether something's collided with something. It optimizes the right way, but you can use that just if you don't want to necessarily specify, I want to check 2 units or 5 units or 1,000 units in front of me. I want to just check forever and see if it collides with something in your scene, right? And then as you can see here, once we have detected a collision, we play a portal sound, we get the right portal, and then we set the portal's transform and rotation based upon the hit's point and rotation. And that's pretty much all that's involved in shooting the gun. And you can take a look through here if you want to get a sense of how it works, and maybe explore also the Raycast, the physics.raycast section of the API, just to understand what exactly it returns and what you can do with it. But in this case, this is how we're using it to detect whether we've intersected with a wall. So it'll intersect with any sort of mesh, and then when it does, it'll tell you exactly how it did. So that is what raycasting is. Raycasting has another name for like old school games like Wolfenstein. The method of rendering was called raycasting, where you would generate one sort of, you would generate a ray from every pixel of the screen effectively, although it was mostly just every line of the screen. And you would just look up and down for everywhere it intersected in the scene, and then just draw like a texture there. And so that would generate a world that looked 3D, but you couldn't move up and down because it was always generating all rays completely forward, and so you were locked onto 2 axes. But raycasting is different in Unity. Raycasting is just literally casting a ray in 3D space versus the sort of 2D space that it was casting in games like Wolfenstein. Here's another screenshot of normals from our portals casting out rays. And I want to look up and see if I can just find a picture of what Wolfenstein looked like. I'm pretty sure most folks are probably familiar with, not the new one. Yeah, Wolfenstein 3D. So this is Wolfenstein. So old school, but this sort of ray casting was different. It would basically shoot rays from every single line of the screen up and down, and it would detect based on the level geometry, which was very simple level geometry. It was just basically whether there was a wall there or not, true or false, kind of like a 2D image. And it would draw, based on how far away it was, that particular point of the geometry, it would just draw like pixels from a texture, a specific texture, at a specific point. And they had to interpolate where on the texture it was, so it was a little more complicated. But in case you see in case you see raycasting used in those 2 different senses, in the case of old school game engines, and in the case of modern Unity sort of raycasting, that is what is involved in that. So any questions as to how, sort of in a nutshell, the raycasting works in the context of our game here?
Are we going to be using the glasses?
So unfortunately, no. The Oculus does not work on Mac. They do not have Mac support. And so we were unable to get a sort of version of it working. We don't have the means to necessarily transport given how much time we had. Now, getting VR working in Unity is actually very easy. If I recall correctly, I have to just remember the exact menu. I had sort of anticipated talking about this before. I think it's player, XR settings. Yeah, that's what it is. So in order to so it's incredibly easy. If you want to do a game in VR in Unity and you have a PC, out of the box, it's very easy just to get it working. All you need to do is go to Edit Project Settings, and then go to Player, and then in the XR settings, so Unity has like deemed all of its VR, AR stuff as XR, and you click Virtual Reality Supported here, and you have your Oculus Rift or Vive or whatever plugged in, it'll just work with the camera, like right out the gate. So it's pretty easy. You may have to install drivers on your computer such that your computer knows that you have an Oculus plugged in, but assuming that's all set up, your project is as easy as just clicking this checkbox.
Which headsets was this for?
HoloLens, Oculus Rift, and I'm pretty sure the Vive, like 90% sure the Vive. I'm not 100%. We can Google it though. Let's see. Unity
Special
5.
developer versions of those headsets, or is it?
More important
it looks like it does. It looks like it definitely does. Yeah, and of course, VR ready Windows PC is very. I apologize. I totally thought going into the course that that Oculus worked on a Mac, but as of even October, they were like, it's not going to work on any MacBook ever released, so only on a PC, unfortunately. That said, if you do have a PC, super easy to get working, and it looks like this is actually a pretty cool tutorial. I haven't looked at this, but I tend to like Ray. I don't know if his name is Wenderlich, but he makes really good game programming tutorials in general. So just, because we're coincidentally here, if you guys are curious, I really like this website for basic tutorial stuff.
Are there other headsets that do work on the Mac? You have Vive?
We have Vive, and Vive, as far as Vive, the thing about Vive is you need to install like ceiling-mounted cameras in order for it to work. So that's kind of out of the equation. We have the Gear VR, but we would need to export it to mobile and test it, and it just didn't have. I didn't anticipate it not working for Mac, and so it kind of came up a bit late, and so it's on me. I apologize, but if you are doing a PC game in Oculus and you want some assistance, I'm happy to help out. It looks like it's very easy just to get working with the default FPS controller camera. So definitely reach out if you're developing Oculus and need some assistance. Maybe for the next iteration of our next Unity course, we can have a big sort of VR day where we bring in all the guns. But yeah, back to sort of raycasting and what we were just talking about. Shooting array on your z-axis based on your rotation, get information from it, and then sort of what we do is we flip the portal based on the hit dot rotation of the surface that we collided with, and that's effectively all the raycasting that we need to worry about for Portal. But the actual making a portal is probably the most interesting part of this whole project, and so let's go ahead and go back into present mode. So a render texture is a basic. It's not a basic means. It is the fundamental way at which we go about doing it, and there are various ways to accomplish doing it. Some that are more technically challenging and look a lot nicer than others. I did a sort of simple version of it, just to get a sort of proof of concept out of the gate. But Unity makes it really easy just to get a simple render texture up and running. So a render texture is, recall, just a texture in Unity. So it's an asset. It's a Unity asset that you can create. The difference between a render texture and a texture that you might have imported from like Photoshop or GIMP is that a render texture can be rendered to. And typically this is used for things like cameras being rendered to it. Although, from what I understand, you can render anything to it, so you can create procedural textures this way as well. But in this example here, we're essentially creating a screen into which we're looking at the viewpoint of our other portal, right? From its forward direction. So we can see what it will look like once we walk out of the portal and go into the next area. And so a render texture, so I have some in the slides. If you want to download the slides, they're here. You can see exactly how to create a render texture. So literally just create and then render texture. That creates a render texture. These are the settings that I used for the actual render texture. So what'll happen, do we think, if we use like a low-res render texture? Just logically. And let's say, what if my render texture was like 200 pixels by 200 pixels? And our resolution of our game is like 1080p.
Will it just be blown up?
It won't be blown up because what we're doing is we're taking a mesh and we're affixing the texture to it, so it'll just scale to fill the mesh. But what'll it look like when it's rendered? Because it's rendering a 200 pixel texture. It'll look pixelated. It'll look really nasty. And so in order to fix that problem, typically what you'll do, a smart way to do it would be to dynamically figure out at runtime what's the resolution of your game, right? If it's going to be rendered in various resolutions, up to 4K, maybe down to 720p, and then create a render texture that is the size of your game. And then by doing that, it'll ensure that no matter what your resolution is, it'll always be 1-to-1 pixel ratio, even if you're right up close to it, right? It'll fill up your whole screen. In this case, we went for a simpler method so we didn't have to do any dynamic instantiation of the render texture. which you can absolutely do, and it is the more robust way to do it. But in this case, I just chose 1024 by 1024, figuring that that was going to be good enough for demonstration purposes. And most of these other settings, I believe actually all of these other settings are completely default render texture settings. The only ones that changed were this is 256 by 256 by default, and it just looks really pixelated and nasty, especially when you're right up close to it. And then all we need to do, so once we've created a render texture, right, in our scene, in our assets. So here I'm going to go to textures. This is where I'm storing all my textures, whether they're render textures or not. I have these two render textures here. And so these are, by default, they're not going to be mapped to anything because they're just empty render textures. We effectively allocated them and said something will be rendering to these later, but for now they're just empty. They're just placeholders, right? They're like blank screens, but the TV hasn't been turned on yet. In order to actually render to them, we go into our first-person character, or sorry, not our first-person character. We go into whatever camera we want to render to the render texture, because we're effectively taking these render textures and we're rendering a camera view onto them, right? Each of the portals has a camera behind it looking out from it, and so we want to take that camera's view and we want to render that onto the other portal's face, the other portal's render texture, the texture that we're going to put onto it. And so all we need to do is say, here's my orange portal. I have my camera here. Every camera has a target texture just right out the gate. So you can just say, okay, I'm going to take my orange portal texture, my render texture that I've instantiated, so it knows that it's going to be able to receive an input source, and I'm going to just click and drag it there. And it's that simple. Now, whenever you run the game, you'll notice that your render texture updates. I'm not sure if it updates in real time in the inspector, but it renders if you're showing it onto a, yeah, it doesn't render in the inspector, but it will update if you've affixed it to any other surface. And so what we're doing is we're affixing it to the meshes that are associated with each portal. James, did you have a question?
Yeah, how did you make the just blank texture that you?
Oh, sure, the render texture. So I just right click, and then I go to create, and then a render texture right here. And that'll give you most of the settings that you need to get up and running with it, and you can assign it to a camera. But the important thing is do consider your resolution for your render texture. Make sure that it's high enough such that your game won't look pixelated when you're looking at it like pretty close up.
So it's as easy as that. You just make the texture and then drag the camera.
Yep. And so that'll do is create a link between the two such that anything the camera sees, it's no longer going to be rendering to the scene or anything like that. It's just going to render to the texture. And actually, I think you can render to the scene and the texture, but these aren't rendering to the scene at all. The only one rendering to the scene is the first-person character, because it's the default camera, main camera.
What happens if you set the resolution too high on the render texture? Like it's 4K resolution on the render texture, you're playing at 720p.
If it's too high of a resolution, it's just going to like compress to fit the mesh, whatever it's affixed to, and you'll probably run into performance problems, but it's not going to break. Yeah, because you're not affixing it to any, because your resolution, it doesn't really have an effect necessarily on whatever's in your game world, and like that doesn't cause any issues. It gets interpolated, like Unity will just like calculate how to render it to the screen, right? Yeah. Like game textures generally are very high resolution, like 4,000 by 2, like 4K textures are often used even if you're running your game in 1080p. And our game engine will probably optimize it and like downsample the texture so that it is like actually a 1080p texture, and you're not trying to calculate more, draw more than you need to. But Unity will figure that out for you. You don't have to worry about that. But yeah, that's what a render texture is, and that's how we are creating this illusion. Remember, everything in the game is an illusion. In this case, we're not actually, and it's obvious in this example because we're not actually, because the textures are flat and there's no perspective correction, you can see that it's a texture, even if it is slightly convincing from far away. Like from far away, it actually kind of looks, I mean, I don't know if it necessarily looks real. I mean, it kind of does, right? Like from here, it's hard to tell. And from here, it kind of looks like we're going into another room, right? If I go like that, that's the broken wall. If I go like that, right? There's a portal there, and it kind of looks like it's a real room that we're walking into. It's just a resolution, but all we're doing is we're just drawing a camera's view onto that texture in real time. And if you notice, you can see our gun. It's kind of hard to see, actually. See if I can do it from from there maybe. Yeah, I see a little bit better there. When we move, we can see the gun, so we can see that it's rendering in real time. And that's the power of a render texture. And this will allow you to do all kinds of things. You can have like, TV screens in your game that are rendering another part of your scene. Obviously, an example like this where you have a portal looking into another area. Now, if you apply a perspective correction to this, whereby your camera actually tracks where your player's position is relative to the portal, you can accomplish a much more believable look. And you can actually make it seem as if you're looking into another area because the camera is literally moving with your player. So the camera's, like the stuff that it's capturing is going to be changing in real time, not only just your character's model, right? The actual angle is going to change and therefore be perspective correct. And there's a awesome tutorial that I'm going to link to in the slides that'll show you how to go about doing that. And it's really awesome. And so this is what it ends up looking like. This is actually before I changed. One of the portals had a slightly offset camera angle. So you can see here, this is like a little bit higher than this one is, even though this should be exactly the same, but it's fixed now. So texture masking. Oh, also, any questions about any of that process before we talk about texture masking? Okay. So texture masking is basically the process. So if we just take a plane and we put a render texture onto it, that's what it looks like. It just looks like just a square. And this could work fine if you want sort of a square portal look. You don't have to do any extra work. But if you want a circle, right, you can't really create like a circle-shaped plane object. That doesn't really exist. And even it did, it wouldn't be efficient, especially if you want a very smooth plane, because everything is triangles and polygons, right? So if you have a circle, it's going to be a bunch of these sort of fanned out polygons, especially a very high res circle like one of these. That's a very high res circle. Making a polygon that looks like that is not an optimal way to go about solving that problem, right? A much more optimal way to go about solving that problem would be to designate certain pixels of some texture as being pixels that we want to read, and then certain other pixels as being not pixels that we want to read, and therefore produce the final image that gets put onto a geometry, right? And so what we end up doing is creating an image first. So it's this image, which is kind of hard to see, but it's just a simple sort of, can you guys see it from the, yeah, you can. So it's just a simple oval, right? It's the exact shape that we want our portal to look like. And the pixels that are white are the pixels that we're going to render. And the pixels that are black are the pixels that we don't want to render. We want to consider those as like pure 0 alpha, effectively. And using an awesome shader that you can get for free just easily on the Unity webpage. This is just a masking shader. And I'm not great at writing shaders. But what this does is it turns lighting off, first of all. What happens if we have lighting applied to our portals? Going to look a little weird, right? You're going to get like shadows cast onto your portals, and that doesn't make sense, right? Because we're effectively supposed to be looking into another place, another area. So if we have shadows that are being cast onto our thing, we're effectively like almost seeing like a glass door on our portal, right? It sort of breaks the illusion. So lighting should be off. A lot of these things I'm not 100% on because I'm not great at writing shaders, but it's a very simple, easy shader that you can grab off of the Unity webpage, and I think I clipped the URL here at the very bottom. But I grabbed that off of the Unity webpage, and all it does is it adds onto your material this second image here. And it gets blown up a little bit because Unity makes any texture that you apply to, basically any texture you put into like an image selector will get made into a square shape, and our image is not square shaped. But what this does is when you pass in this image, which is called a culling mask, it will basically combine the two images and then cancel out any of the pixels that are black on this. It'll effectively add the black and white to the alpha of the texture pixels, right? So you can actually make some of these gray, and then that'll have the effect of sort of making it half transparent. But in this case, I only went with full transparent and full hard 255 alpha. So we get sort of a crisp outline for our portals. And that's how you end up putting together a basic sort of oval shape on something that is just a flat mesh. And you can do this with anything. Anytime you need to sort of take away detail that would make making a mesh extremely difficult or doing really cool effects, it's often just a lot easier to create a mask for it and then use the right shader that's meant to have that mask and then just manipulate that however you need to. And again, the link here for the shader is here, and then you can use this for pretty much anything you want. End result of that is we go from having a square portal to a elliptical portal. So pretty nice. I didn't have to use a plane, but it doesn't really make sense to use anything else. Because using a cube, it would create depth. We don't want the portal to have any depth really, right? It's just be a flat surface. And then when we go through it, it's just teleport us to the other surface to make it look sort of seamless. I don't think there's another choice of geometry that makes sense for this use case.
You wouldn't just make a cylinder flat to have no depth and then project on it?
No, I probably wouldn't. Make a cylinder flat and project it and have no depth on it. You would be able to still see the rings on it, and also texturing that is a little bit more complicated because then you'd have to UV map your both your sort of mask and your regular texture onto that, because by default it's going to wrap it weird just because this is just a plane, so whatever you texture map onto it is just going to be completely flat. But a cylinder is going to wrap it around all sides, and it's going to look a little bit funky. I suppose in theory you could use a cylinder for it, but I think it would be a tremendous amount of work. I don't think it would be anywhere near as easy as getting it to work with just a flat plane or a mesh. Interesting idea though. I guess you could theoretically create a cylinder that has, if you wanted to, like a bridge between two worlds and have one end be one portal and one end be another portal and then be able to walk between them. That's a cool idea. Maybe you can make that work. But I think for this, the plane is the right way to go. Any more questions as to sort of how that works? All right. So we'll talk about teleporting now. So teleporting is pretty easy. All we really need to do, right, is just create a mesh collider on the portal mesh, the orange portal and the blue portal. And then when that mesh collider, if that mesh collider is a trigger, right, and it detects a collision with something else, we can just define on trigger enter. And then with that, we can teleport the collider other to the other portal's location. So every portal, this is the portal component. It has a linked portal, right? Because we need to know where to teleport the player to the other portal. So we need to have a reference to its transform. Whether it's active, right? Because if we allow ourselves to teleport to another portal and another portal, like back and forth, just without any restraints, what do you think is going to happen? Infinite loop. We just get an infinite sort of weird flickering effect. So you need to effectively have like a toggle switch on both portals and say, as soon as I enter a portal, I should not be able to teleport back into it, right? And as soon as I teleport to another portal, I should not be able to teleport into it either. But once you exit a portal, you should be able to teleport back into it. And so what that effectively does is we enter a portal. It gets flagged as not teleportable, right? We get teleported to the other portal. As soon as that happens, this portal can now be teleported into. This portal that we're standing in is now flagged as not teleportable. And then we walk out of it, and we're allowed to teleport back into that one and the other one. So it's effectively an on-off operation that you have to balance appropriately. The actual portal game is a little more complicated because they allow you to walk in between portals. This does not go into that level of detail, and it's a more complicated problem to solve. This example just assumes that you walk into a portal, you get teleported out the other end, and there's no sort of in-between state. And actually, if you're in between two portals, there's a replication of geometry, which Valve will talk about in their talk as well, which I think will be very interesting, because if you look into another portal while you're in the middle of a portal, right, you want to be able to see yourself, in that portal, right, halfway in and out of that portal. So there's a a lot of interesting considerations for getting very believable portal systems, but ours is a very simple illustration. And so this toggle function is all that I have to toggle the function's on and off capability, and all it is just portal active is not portal active, and that just flips that flag. Super easy. On trigger enter, we effectively cache our position on the X and Z axis so we don't rotate it, because when we rotate our X and Z on the first person controller by default, it causes some really weird buggy behavior based on the way that the FPS controller works. So all I do is I just cache those positions and then make a rotation on the Y axis. And that'll save us that weird sort of going topsy-turvy effect that you'll get. If you use the FPS controller by default and you do perform rotations on it, you'll notice this. So I haven't had the time to dig in depth as to how to fix it, but this is the way that I was able to fix it for this example, at least, is only allow yourself to rotate on the Y direction, which is where you're looking in sort of like the ground, relative to the ground plane. And that'll allow us to rotate based on where we're exiting the portal, at least on the sort of walls that are going up and down, and then have that sort of believable effect. It doesn't allow us to like jump down into a portal from up above and see us coming down from the other portal, which is a cool effect, unfortunately, but it does allow us, sort of to get most of the way there. And so we set our position to the other portal's position and our rotation, but only the Y. We get the Y, and then we set it here using Euler angles on our player's transform. And then there's a function that I created called mouse reset, which effectively just calls init again on the FPS controller's rotation on the camera and the player. And then that's sort of like the hack that you need in order to... The reason that a lot of the weirdness exists is because the player controller caches its rotation information. And so if you perform a rotation on your FPS controller by hand, as opposed to allowing it to happen with the mouse, it will immediately reset it back to its prior position and rotation, which has the effect of when we teleport from one portal to another, even though we set our direction of rotation to be like outside, going in the direction of where the portal's facing, we end up having the same position, the rotation that we did entering the portal. So we end up coming out of portals often just backwards. And so that's just a limitation of the first-person controller, but you can fix that by calling mouse reset, which is a function that essentially just calls init again, init is part of the FPS controller's mouse look object. I won't go too much into detail about it just because it's a little bit arcane, and the source code's in there if you want to take a look and dabble with it. But effectively preventing it from caching its rotation information and just hard setting it, and then recalling the mouse look init function, which does the actual setting of the rotation on the camera and the player. A little bit weird, but that's Unity's FPS controller, and that's how other people are saying to fix it. So you could roll your own, you could create your own FPS controller and probably prevent this from happening. But if you want to use the regular FPS controller, that's sort of the limitation there. But it's mostly working, and it looks pretty good. Some more time on it, and we could probably make it look even better, but for now, I think it's good. So that's teleporting. Set your position, and then set your Y rotation, override the FPS controller's default rotation caching, and we can walk in this portal and then instantly walk out this portal, and that's what we see. So any questions as to how sort of this works in a nutshell? Or maybe any of the code here in our portal? All right. So a much better version of the portal, at least from the rendering side, is this video here. So it's Bracky's. So he's a very good, he explains things very well. He's got very high quality to his videos. He creates a bunch of Unity tutorials, and in this case he created a portal that used a sort of shader, an interesting shader that'll only render everything but geometry, and also onto a plane, in which case this plane, and does the camera interpolation of the player that I alluded to before, which allows us to actually have so these are two separate worlds in tandem right now. So there's this red world here, and then this camera is looking at a completely different green world that's completely like set off in the distance. That's the exact same geometry, but completely colored green as opposed to red. And if you look through here, it's just completely seamless, and the walkthrough is completely seamless. And he goes into detail as to how he accomplished all of this if you're curious, and he provides you the shader that you can use for free. So definitely check that out if that's of interest. There's a link there in the video, and here's a link to his YouTube series if you want to. I put some of these in the Slack because somebody requested some AI videos, and he has a bunch of different AI videos and a bunch of other really cool series, so you can take a look at that if curious. And the best version sort of Portal obviously is Portal itself. And Dave Kirscher and Tajiv Kohli are employees at Valve who worked on Portal, and they'll be here on May 2nd to give a talk as to all of the technical sort of things that went behind the scenes and related to rendering and physics and just getting a believable and good feeling experience with Portal for the actual polished final game that we're talking about. So definitely come to that talk if you're curious. We're going to take a break, and then as soon as we come back, we're going to talk a little bit about some new tools that Unity has released called ProBuilder and ProGrids, and we'll talk about the assignment. And that'll be it for GD50. All right, welcome back. This is lecture 10. So we talked about Portal before the break. We talked about Raycasting. We talked about RenderTexture, sort of what those are, how easy it is to make those in Unity. We talked about how to give our first-person controller a gun so that we could actually look around and look as if we're holding a weapon. We talked about the portals themselves, how we're masking out the texture, the render texture as applied to a plane, and how each of those has a camera behind it so that it can render what is going out from the portal in the direction that it's facing. We're going to deviate from Portal now and talk about ProBuilder and ProGrids, which are two tools that are part of the new Unity 2018.1, which will allow us to actually model geometry per the screenshot. This is actually a level that I created and that is in the distro. It'll allow us to create geometry in the actual scene view without needing to go into a third-party program like Blender or Maya and have to sort of alternate between the two and import and export, incessantly. Not only that, but as soon as you model something like this in Unity in the scene view, you can immediately test it for gameplay and make sure that it actually fits what you want, and you don't have to worry about scale issues when you're importing and sort of making it work and figuring out ultimately that, oh, I don't like the way this level is, let me go and tweak it and redo it. It just allows you a ton of ease and flexibility. And I previously mentioned Bracky's before, but he's got a couple of awesome tutorials here on ProBuilder and ProGrids to supplement sort of what we'll talk about today in lecture. But if you want sort of more of a showcase of all the features of both, then you can look at these videos here and get a sense of how they work. So we're going to go ahead and just mess around with ProBuilder a little bit here in the scene view so that we can see what it looks like. I'm going to open up my other scene. So I have the Portal scene. If you're in the distro, this is where all the stuff that we've been looking at exists, just the Portal game. There's a ProBuilder scene as well, which I'm going to not save that. And so this ProBuilder scene is the level geometry that I created earlier. Now, it looks pretty horrendous because I didn't spend a terrible amount of time on it, and I'm not a particularly talented visual designer by any stretch. Let me go ahead and make it a little bit larger so that we can see it a little better. But it showcases some of the interesting features. So we see, we have obviously sort of polygonal, square-shaped, rectangular geometry. We can see that some faces are textured and some aren't. So we can see this face here, for example, is just white material, the default material. We can see that all of these sort of have this brick texture, which I got off a procedural generator website that allows you to choose a template for your texture and then specify colors and stuff like that. I did the same thing for this texture. This is another procedural texture, which is kind of like a blue marbly type texture. The cool thing about it is, at least for texturing, you can just choose arbitrary faces that you want to texture rather than have to texture the whole thing. Like you would do if you were to just give a mesh a default material, it'll apply it to the whole mesh. In this case, it's just applying it to whatever faces we select in ProBuilder. Another interesting thing which I really like is ProBuilder gives you a lot of tools for creating special kinds of geometry very quickly and efficiently. In this case, this is a staircase, which all I had to do was, with ProBuilder, select Build Staircase, and then you can choose a lot of different parameters. We'll take a look at how to do that in a second. I did the same thing here. So notice this staircase has kind of a spiral to it, and then this staircase is really tall but has no spiral. And then we have another staircase here which is kind of shorter and doesn't have a spiral, and then it ends up coming up here to this point. And then if this were the assignment, maybe this spot here would be where you put your collider that says, oh, this is the finished, this is the level's conclusion, you've beaten the level. So the assignment is with ProBuilder, so to make a level, it doesn't have to be anything terribly fancy, like I'm not a great designer, but it should have at least one section where you're required to jump, so some sort of jump puzzle, just so that you can, think about the design of your level a little bit. And it should be, meaningfully large, not like, it doesn't have to be gargantuan, and it shouldn't be small. It shouldn't be like 10 meters or, maybe not 10 meters, but it shouldn't be like, 5 meters large. Obviously, that's very small. It should be something that you would consider, a somewhat sizable level. Using something of this size is a fair metric. So ProBuilder. If you've installed ProBuilder, so by default, ProBuilder is not installed in your project. You have to go to the asset store. I don't know, asset store's been a little bit slow last couple of days. We'll see if it works quickly. Looks like it is. So if we go to the asset store, open this connecting again, being slow. Okay, so if you search for assets and you just type ProBuilder, it'll pop up here. And notice that it says Unity Technologies. Anything basically that says Unity Technologies will be a free sort of supplement to Unity that you can easily just import from the asset store. Now it's a little bit cramped, the window here, and because I'm in a 720p monitor, but you just have to click download and then import in order to import it into your project. The distro for Portal for assignment 10 already has ProBuilder and ProGrids installed. ProGrids would be the exact same process, just ProGrids right here. And when you import both of those into your project, you'll immediately have the ability to go up to Tools, and you'll see ProBuilder and ProGrids here. And all you need to do is click on the ProBuilder and then ProBuilder window, and you can see here this nice little widget-filled window pops up, and you can also dock it here if you want to. I actually did that on accident, but Unity makes it pretty nice so you can dock your stuff wherever you want it to. And there's a few different things. So you can do new shape and a new poly shape. The new shape actually gives you like shape templates. So here I've chosen just cube by default, and it allows you to do stairs, prisms, cylinder. So I can just do a stair, for example, and then we immediately see this like stair mesh here, right? I can generate the number of steps that I want just by changing the slider. I can change the curvature if I want so that it's a rotating staircase. And then I can also change how wide and how tall the stairs are. And also this inner radius is like how deep the steps are, if that makes sense. And then all of these together, once you finish, you just hit build stair and it's done. Now you have a stair mesh that you can just put anywhere in your level, and it's that easy to make stairs. Before I get into more of the sort of what makes ProBuilder work, I'm going to go ahead and enable ProGrids. So ProGrids is a cool feature. It's a cool, add-on, which will actually lock everything in your scene to a specific grid, which you can designate based on how fine or coarse you want the grid to be. And what that'll allow us to do is when I move, notice that it's moving on the grid, right? It's not moving in continuous, like sort of a continuous motion. It's actually discrete steps. And the advantage of doing things this way is that when you're modeling your level or whatnot, let's say you have maybe a sort of a diagram or a drawing that you've created, you slap it on a texture, a flat mesh in your scene, and then you just sort of draw your level on top of it. Everything will sort of just like map up nice and cleanly when you're creating all your geometry, and you can snap things together and align all on the same axes. And it makes creating levels like this just a lot easier. You don't have to worry about things being slightly off and then like missing vertices and everything sort of be looking a little bit unclean. This ensures that everything is very clean. So again, just notice the discrete steps that it's moving. These are all locked to the grid here. And so you can change all the settings here as to like how large it is. If I create a cube, so I'm going to go ahead and create a new cube. I'm going to build it. Notice up here, these 4 buttons are sort of like the modes with which we can interact with our cube. And this is very similar to what you get in 3D software like Blender or Maya or whatnot. You choose vertices with the left mouse, and then you can hit shift to select multiple, and then you can just move it. And since I'm using ProGrids, it's snapping it to the grid, right? So if I turn off ProGrids, it should just be continuous like that. And so you can get whatever sort of angles you want, depending on what your use case is. So I'm gonna go ahead and hit Command Z. If I click on the face mode and I click this face and I shift click, it'll actually extrude it and make a new face. And I can keep doing this sort of over and over again. I'm going to zoom out a little bit so I can see a little bit better. And I extrude that, and then I extrude that, right? Starting to build something, right? It's not beautiful, but it's something. I can extrude that again, right? I believe I can scale as well. So you can build it out like that. And I haven't spent a ton of time mastering how to use the tool and all the ins and outs of it, but it is very, I think, useful if you're looking to get into sort of level design and you want to avoid the overhead of dealing with third-party software like Blender or Maya and having model files that you're sort of importing and exporting. It can be kind of a pain. However, if you want to export models, you can definitely do that. So there is a method here. Forget which one it is offhand. I think it's this one. No, it's one of these allows you to save the model. I don't remember exactly which one it is. Is it this one? The menu is a little bit cramped here, so I'm going to actually blow it up. Yeah, offhand, I can't recall which of these allows you to actually export. I don't have the icons memorized yet because it's a fairly new tool. But one of these will allow you to actually export the object as FBX or OBJ, whatever your software is that you end up wanting to. So you can just also go up here to the export menu, which is a lot easier to see everything by name, and you can choose how you want it to export. You can also export assets too for your game. So you can have objects in your scene that ProBuilder will generate for you, so you can create prefabs that way. But then here's like OBJ, so that you can export it to your 3D renderer, 3D software of choice. This is relevant for situations where, for example, you want to like rig and model and animate a mesh. You can't do any sort of rigging in ProBuilder, but you can do that in other 3D software, so it makes sense to export it that way. You can also create the model here, export it, rig it, and then re-import it if you want to, and that's relevant.
But that's a usable scene as is right now.
This is a usable scene as is right now. The lighting gets a little bit messed up. Notice here when you mess with stuff, but that gets fixed. There's a little sort of meter here where it does some calculating, and by default it'll actually bake lighting on all of your objects. But as is, this will perfectly collide with any characters that you have. So I have a FPS character. I'm gonna bring this guy up. Let's go ahead and set the transform up here. Just put him in the right position. And ProGrids is like attaching that, like sort of making that grid visible next to where I am, and you can set the access for that. Currently I have it actually disabled, so if I enable it, now this will actually move in increments, see? And it'll snap it to the grid perfectly. But now this, as soon as I hit play, I'm actually going to close this. I should just be on this mesh up here. Yep. And so this is just part of the scene now. Like as if you had made it in Blender or Maya or whatever. You should jump down to my actual level and then explore it a little bit. This is all just haphazardly created, whoops, stairs and other meshes and stuff. And so, make it all the way to the top. Whoop, I fell down. I'm also horrible at playing games. But this is the beauty of it is you can just play it instantly, right? Right out the gate. Now, another cool thing that I'd like to showcase is what we talked about gray boxing earlier. For making interior levels, gray boxing is the purpose of making levels and testing them for playability. The cool thing about ProBuilder is that it has an invert normals feature, which I think is just generally accessible in 3D software. I don't know offhand which menu it's in. Actions, geometry. Do I have the right thing selected? All right, I'm going to open up the ProBuilder window. And then one of these is invert invert selection. Sorry, wait. Flip normals. There we go. And so what this does is now this is an interior level. So all we did before was we made a sort of like polygonal creation of arbitrary size and shape. If you invert the normals, so recall every like 3D polygon, 3D surface has a normal in whatever direction that's facing. Going the opposite way, going towards that normal is what gets rendered. But behind it, if you're going in the opposite direction of the surface normal, it's invisible. And so the effect of that is if we flip all the normals of something that is convex, we get an interior scene. And if we're looking at it from the outside, it looks a little bit weird, right? Like we can see into it, right? And this is something that you might see like in Minecraft, for example, when you're looking in part of the geometry that you shouldn't be able to see. You can clip through the world and see all the other like interior parts of the world because you've basically gone beyond the surface normal of that polygon, and you're only seeing from that perspective all the surface normals of polygons that are facing in your direction in that way. But often you'll allow you to look straight through all of the other sort of cubes that are along the way because you're looking at all the rear of their, the inverse of their surface normal. You're looking in that direction. And so again, only one direction can a polygon be lit at once. And even if we look at it from the top, you can see that as well. We're looking at it from the top, flip the normals. It becomes a sort of concave or a convex 3D object, flip them, now it's an interior level, right? So I'm actually going to go into this, and I'm going to flip the normals again. I'm going to click on this. I have to click on a lot of these actually because it split up the mesh, but it's going to be easy enough. I'm clicking all the top surfaces of this, making sure I didn't get any on the other side on accident. I did not. I'm going to extrude this. And then I'm going to flip all the normals. And then I'm going to take my FPS controller, which is here. And actually, I think it's already inside, which it is. I'm going to hit play. The lighting, I'm not sure if it'll be messed up. It is messed up because it's in the middle of calculating a bunch of stuff. But now I've created an interior level, right, with the weird mesh that I had before. And so if you sort of make the building of your level sort of, this concave thing, and then you flip all the normals, you can create an interior scene very easily with ceiling and everything else. Normally, otherwise, it would be kind of a pain in the butt, but it makes it super easy to do with ProBuilder. And there's a lot of other features. A material editor for one. So with the material editor, you can actually designate specific materials. So in this case, I've created a couple of materials, a brick texture here and a marble texture, which is just I took some textures, created a material, made the albedo component of those materials that texture. And what that allows me to do is I can select an arbitrary face. So in this case, I'm going to choose these faces. And I can just click on this brick texture. And now these are textured as that brick, right? It's not applying it to the entire mesh. It's just applying it to whatever specific face that we want to. And there's a UV editor, which will allow you to actually take the mesh of your model. In this case, this is our entire mesh here. Just remember, as we talked about it last week, everything gets cut out and made flat. So you can sort of see, if you remember the shape of what we're dealing with, all the polygons that we were, that comprised our sort of weird large object. They're all now splayed out for us. So we can just very easily take a texture and just like put it wherever we want on here. Now, I don't have a ton of experience using this, so I'm not 100% confident in my ability to UV map something right now in front of you, but the documentation on the ProBuilder website goes into detail as to how to use this. So if you wanted, say, a specific texture to be like in part of the mesh and then maybe another texture to be on another part of it in a specific like welded way that's not like just splat onto it, the UV editor will help you with that. For example, a face on a character model or something else. But yeah, or maybe like a sign on a door somewhere or something like that. You can do that all here. Just click and drag all the faces. The faces are actually dependent from one another so that you can lay them out in a way that fits the texture that you are trying to map everything to. That is ProBuilder in a nutshell. There's a lot of features. We don't have time to cover all of them, and I mean, frankly, I just don't know all of them super well yet, just because the technology is so new. But I think this is going to be a huge part of like Unity's future, and like making it accessible for people that would otherwise have maybe been turned off by the idea of modeling their level geometry or their object geometry. I mean, certainly for me now, this just makes me want to make a game in Unity like right now, just because I know I can instantly just like start creating my levels, right? Like it's just nice and easy and convenient. And ProGrids, you should definitely use ProGrids in tandem with ProBuilder so that you can optimally rearrange things in a way such that they're all like evenly lined up with each other. Otherwise, you're going to end up with issues in like manipulating their position in a very specific way and like coming up here and setting their values manually, and that's just kind of a pain. So much easier just to snap everything to the grid, the ProGrids, and deal with it that way. And so the assignment is, largely just going to be take ProBuilder and ProGrids and just like make a level with it. And then just like take the principles that we've learned, create a controller, create a collider, and just make a very simple scene, and otherwise probably spend your time focused on your final project. So any questions as to ProBuilder, how it works, how to get it set up? Yeah.
So what would it look like? Can the character actually stand on top of an object that has normals inverse?
No, it should flip through it. Let me go ahead and put this up here. It actually it might not. I think it does still trigger collision, but you'll just be able to walk. You'll just be able to see through the It's
just visual, like the.
Yeah, it's just a visual bug. It's a lighting bug. The physics should still apply. I'm going to go ahead and set the model up here. Okay, hit play. No, actually, it looked like it went through it. So I think it also inverts the collision box. Yeah. I've seen some games where you can clip through something and still collide with it. So I think it depends on ultimately the engine or the implementation that you're using. But in this case, when you flip the surface normals here of this mesh, it also flips the box collider, the mesh collider's normals. Yeah.
The obvious thing to do would be copy it, size it up a little bit, and then not invert it, and then you would have a kind of inner and outer layer, which would let you have both. Precisely,
yeah. If you wanted, you could make a copy of the interior. You'd have to make it. You make it the same size, I suppose, and then not flip its normals, such that you have a shell and an interior. Yeah, absolutely. Generally, I don't think you'd. I mean, it depends. If a lot of interior levels, you'll never ever be outside of their boundaries, and so you don't often see that happening. But it's very much the case that you could have that happening. And if you have like a house model, for example, then you'll actually see house models are modeled with walls that are two planes. So there's a bit of thickness. It's actually a rectangular shape, so it allows you to have a collision on one side and another side. Because there's two planes of the collider, rather than just the single plane, which is the direction of the surface normal. Any further questions on ProBuilder? Yeah.
So how come you can fall through the ceiling but not through the floor? Like, is the bottom and the top?
Because the bottom surface normal is pointed upwards. So this right here is pointed upwards, but notice that here the surface normal is actually pointed down. So you can only collide with the direction of the surface normal that's facing you, if that makes sense. You can walk towards the direction of the surface normal, but not like against the surface normal, if that makes sense. That's the way that Unity calculates its mesh renderer component.
What about the left and the right? So the left is, can you go through from the left to the right?
You could go through from this direction, but you could not go through this direction. Because this direction, the surface normal is pointed this way, right? So if we try to walk against it, we'll be walking against the normal, and so we won't be able to, we will trigger a collision. But if you're walking through it in such that you're going the same direction as the surface normal, so if you're coming from this direction, then it won't detect a collision. Does that make sense?
Yeah.
What Tawny suggested, which was to make a shell around it, would solve that problem. So if we created this exact mesh, duplicated it, and then inverted it, then we would have two of the same object, but with normals going one direction and normals going the other direction, such that the mesh renderers account for both potential movement directions. Cool. All right. Any further questions on ProBuilder? Again, not meant to be a comprehensive tutorial. There's videos and documentation that I've linked to in the slides, but more just to illustrate how awesome this tool is really, and that this is probably going to save some people doing Unity projects some time if you're doing any Unity, like if you're doing any asset modeling, I should say, or level modeling. Another thing that I didn't make a slide for, but which I talked about in class was Shadergraph. And so what Shadergraph is another 2018.1 feature, which allows, rather than having to write shaders in ShaderLab, which is Unity's shader language, which can be quite an experience, quite intimidating, you can actually create them now with this node-based programming language. Not really programming language, but this node-based programming environment, I should say, which will allow you to choose all these preset nodes that influence the shader's behavior. And there's a lot of different kinds. And have the result of that be, you can see your shader every step of the way. So the shader is just a series of transformations going from left to right in one direction. All of these sort of transformations, you can see how they end up accumulating to produce this final effect, in which case here, if it may be kind of hard to discern, is a sort of marine guy with these blue holes that are actually like masking his mesh. And we talked about masking earlier. This shader itself looks like it's applying a mask with this noise that it's generating, and it comes with noise generation functions, generation nodes, which will allow you to feed those into sort of like the mask component of your shader and then produce some very interesting, cool effects. Otherwise, this would be kind of, unless you're like a shader expert, which I am not, it would be pretty complicated and non-trivial to implement something like this with just code, but this generates code for you such that you don't have to actually write any code at all, but you can still see the produced shader that gets created for you from ShaderLab or Shadergraph. I believe that it's just a asset now. I'm not 100% sure. I didn't test this going in. Hopefully I'm not just missing it. Supposedly you should be able to just import it. I'm not 100%. Let's see how you actually, this article maybe uses it. Via the package manager. Package manager. I think this is a new window package manager. So we go to window and then package manager. And then all. And then Shadergraph. Yep, so right here. So window and then package manager and then Shadergraph, and that will allow you to import the means to which, by which to create these sort of graph layouts if you're using 2018.1, which the course is using. But if you're at home and you're using 2017.4, then update to 2018.1 and you should see this in your package manager. And then once you do that, you can actually create a new Shadergraph object, and then you'll see it as a new window that pops up in your scene, and then you can start adding nodes. I don't have any material prepared for it, and I didn't anticipate talking about it necessarily, but it's something that seems to be very game-changing, and it's something that Unreal has had for a long time that sort of differentiated it from Unity, in my opinion. And it's, I think, a very valuable thing that they've added that shows a lot of awesome progress for 2018. So, again, a link to Brackeys if you want details on how to use not only ProBuilders and ProBuilder and ProGrids, but a lot of other awesome features of Unity and to do a lot of cool stuff. He makes some really cool videos. Assignment 10. So assignment 10 is going to be creating a level with ProBuilder, just to get your hands wet with it. The level should be pretty complex. So not, like I said earlier, not like a finished game level. Like I'm not expecting you to do awesome, amazing, incredible things, but a level that has maybe a few pieces of interesting geometry, maybe generate some stairs, it has some pipes you can generate and some other things. Have a jumping puzzle in there. So this says there should be one jumping puzzle for the player. The assignment doesn't officially say it yet, but I'm going to make the change to make it say that there should be a jumping puzzle. You can interpret this however you want. Just a couple platforms is fine, but honestly, whatever you would like. And have 2 different textures or materials. So you can create just an easy, just import whatever texture you want, or you can go to a website that allows you to procedurally create a texture. And you can assign it to a material, put it in the material editor of ProBuilder, and then use that to assign it to a face or to the whole object if you want to. But it should be at least 2, not the default. So to make it a little interesting, you can use many more if you want to, but only 2 are required. So this should be kind of like a complete scene. So make a new scene, separate from the ProBuilder scene, separate from the Portal scene. Include an FPS controller so that we can move around the scene immediately after creating the mesh, right? But that's it. You can just use the default controller. You don't need to do anything fancy. And then at the very end, you should have a trigger on a collider somewhere, which it can be invisible. It doesn't have to be invisible. You can make this whatever you want. You can make like an arch or, I don't know, your imagination is, you're free to use your imagination as much as you want, but there needs to be some collider, whether it's invisible or not, at the very end, and a trigger. It needs to be a trigger, and then when you collide with it, it should say level complete on the screen. So just take a text object from Unity 2D, part of the canvas, just drag it. If you just add a UI text in the scene, it'll automatically add a canvas and an event system for you. Create the label and then just set it to on or off depending on whether or not you've collided with the trigger. There's code for this in the helicopter game in the game over text script. You can see exactly how this is done. All it effectively is setting the color of the text to 0000 versus 0001 or whatever color you want to, effectively just a change on the alpha component of the text color. And then once that's done, then you have a complete assignment, and then you can spend more energy. Hopefully this should only take maybe an hour, maybe less. You can spend more energy on your final project, which will be due on the 11th. But altogether, it's been an awesome pleasure teaching this course, and I hope that a lot of you were able to learn a lot of interesting things, and hopefully were inspired to create some of your own projects, and will continue to create some of your own projects in the future. I certainly enjoyed making a lot of the stuff, and especially Super Mario Brothers. I think that was my favorite. But this was GD50, so thank you so much.